Hello friends, I am Dr. Amit Gangwal, Associate Professor at SVKM's Institute of Pharmacy. This is the course for pharmacy students, research scholars, faculty members, and professionals from pharma industries. The name of this course is AI in Pharmaceutical Sciences. AI for AI, that is, for actionable insights, only AI is the solution. For ready to use inputs, one has to go for AI only, and its subtype, that is machine learning and deep learning. So in this course we have taken major content from Simply Learn, basically a world famous online video tutorial website. This is Simply Learn. If you will write in YouTube, you will find hundreds of thousands of original videos of this world famous online course creator. I am thankful to this because I have taken various images from their videos. I am thankful to them. Then we have taken few images and a screenshot of the slides from zitinkilab.hms.harvard.edu. They have put few slides about AI tutorial. From those tutorial slides, I have taken few screenshots. Then there was an article, AI and big data for coronavirus pandemic. From this paper, I have taken few screenshots. I am thankful to this paper researcher also. Then one teach open CADD tutorial has been put on the video. I mean the codes have been put on github.com. From there also I have taken few snapshots of their coding. Now this is disclaimer, because this course has been made possible from because of various content we have taken from online. So all logos, trademark, brand names and other copyrighted materials, patented things, products, proprietary technologies are of the original creator, individuals, organizations, publishing houses, video, blog, website owners and intellectual property right holders of this content. We have no claim whatsoever on those innovations and other things. The sole intention of using this innovative stuff is to bring readers, learners or participants who have enrolled in this course as close to concepts from viewpoint of originality as possible for better understanding of the subject matter. The same holds true for certain illustrations, images, infographics, flowcharts, etc. We express our deep sense of gratitude to these powerhouses of talent. Images have also been taken from internet using Google as search engine. We don't have any copyright claims on these images and infographics or other material. We are thankful to original content, image, infographics creator and this talent house of power. A few very beautiful and original images we have taken from online course leader. As I told you, Simply Learn, Edureka, another famous brand name for creating online courses on emerging technology like AI, machine learning, deep learning, blockchain, data analytics, and other things like cloud computing and others. We are thankful to them also. We have tried to quote original source of such content, images besides content or image on each slide whenever content has been taken. Various web resources from where we have taken information, content, knowledge, images, logos, screenshots, structures, codes, Jupyter notebook codes, screenshots, GitHub codes, screenshots, official AI, tech, pharma and other organizations websites we have referred for taking latest and first-hand information from those who are doing things using AI. On next 14 slides, we have mentioned such web resources which we have browsed using Google as search engine. We are thankful to these resource creators, researchers, scientists, organizations, IPR holders, etc. Without those resources, this course would not have been possible. This course has been created from viewpoint of latest in the field of pharma, AI and tech, from viewpoint of applications of AI in drug discovery and applications of AI in other pharma domains like clinical trial, marketing, management, QA, QC, and other domains of pharma. So to give the learners first-hand information, we have taken latest information from media also, from print media also, blogs, websites, and newspaper websites also, because the intention is to give latest to the learners and all those who have enrolled in this course. So we are thankful if we forgot to mention some paper, article, or references, then we seek apology from respective IPR holders. The intention is not to skip anything, but by mistake if we forgot something, then we seek their forgiveness. So these are the references we have used. Most of the content we have taken from blogs, websites, and other things. So these are the references. Another reference is this one. This is another reference. Okay, this one is next slide of the references or the content from, I mean the sources from where we have taken the content, because most of the things are still in the website only and their video only. They are yet to be published in some research article, review article, and also in some textbook. So the motto is to bring content from various hottest and latest resources. That is the main motto behind exploring all these websites. Next is this one, this one, this one, this one. So total 14 slides I have put for mentioning those references. So now we are coming to the most important point in this course. First of all, I congratulate all the learners, participants, or those who have enrolled in this a typical course, that is AI in pharmaceutical sciences, because you already have come one step ahead compared to those who have not enrolled, or from compared to those people who are not realizing the importance of this AI, because everywhere there is AI. If you talk about the choices or the online advertisement or recommendations on various websites, for example, if you are browsing something, you are purchasing something on amazon.com, then Amazon will show you next time the products which have been browsed by you or the products which have been purchased by you. So this is, I mean, AI or machine learning based ready to use insight in terms of advertisement. If we talk about I mean the riding hail applications like Didi, Chaksu, Uber, Ola, they all work on the principle of deep learning. Then if we talk about online pharmacy, they have the data based on input given by you. They recommend products. For example, if you are purchasing Lantus, a product belonging to insulin category, and it is by Sanofi. So the moment you click or the browse insulins and you click on Lantus, or for example Novo Rapid, insulin from the famous Novo Nordisk company, in that case they will show you, or there will be popping up of all the items which have been purchased by earlier customers who are or who belong to diabetic category. So this is called association rule learning. The machine learning is learning what are the products which are purchased together by diabetic patient. So this is another example of machine learning, right? If we talk about the playlist choice or the video which are being played for you on YouTube, or the movie recommendations on various platform like OTT, like Netflix, Amazon Prime, or others, so they all take huge amount of data and they give you best possible output in terms of your liking. So they are the output or the products of AI algorithms. Okay, so moving on to course content for this particular course. In this course, we will around 70 tutorials are there. Highly lucid content is there from viewpoint of the students of pharmaceutical sciences, and even for the professional from pharma industry or life sciences people like nursing, dental, or medical field. They can find this course useful because the coming era is of AI only. Even for medical people, for the radiologists, there is there is what we call it, medical imaging. So lot many deep learning algorithms are scanning mammograms, CT scans, MRI film, or pathology data, or what we call it X-ray. A lot many data is there. So after training machine learning model or deep learning model will tell you what is the what is the chances of a patient of becoming victim of so and so disorder. Just by studying the earlier history of hundreds of thousands of images, machine learning learn to identify the anomaly or the abnormal pattern just by seeing the image of CT scans or other medical images and comparing with other healthy volunteer. Machine learning will give you, I mean, doctor or pathologist or radiologist ready to use actionable insight in terms of output. So we will talk about, if you see the first point, we will talk about introduction to disruptive innovation. What do you mean by disruptive innovation in Industry 4.0? We will talk about basics of AI, that is artificial intelligence. We will talk about basics about machine learning, that is ML, deep learning, that is DL. We will talk about various types of AI and machine learning. For example, machine learning does three types of tasks: classification, regression, and clustering. So what is the meaning of classification? So for example, you have hundreds of molecule belonging to diabetes treatment and for treatment of some kidney problem. So machine learning will study the features or the descriptors of those particular drug molecule, and without any programming, machine learning or deep learning algorithm will classify the data based on some common points in both the group. Or if you talk about unsupervised machine learning, when you have data but you don't have the meaning of data or the hidden pattern in the data, or you don't have the output or the label of the data, in that case deep learning model will automatically segregate or make the clusters of data. For example, these are the images which are looking similar, so I am keeping those images in one group. So for example, you are showing images of apple and banana to the machine learning model. So without any further information or input, machine learning or higher type of deep learning model will segregate or categorize or make clusters of two type of molecules, I mean two type of fruits, apple and banana. But machine learning will not label it, it will just segregate or give you the clusters of two groups. Then you have to put the name. Okay, this group is apple and this group is banana. So that work you have to do. It is called classification or clustering type of problem. Then we will talk about deep learning. Deep learning means the use of artificial neural network which is based on the functions of human neurons. And when there is simple cases like correlation, we can go for simple machine learning algorithm like support vector machine, decision tree, and random forest, naive bias, k nearest neighbor, or k means clustering. But when there is multiple features, or when there is multiple co-linearity, or when there is no direct correlation between x and y, when there is complex type of correlation or some relation between the x and y, you have x that is independent variable, that is input or feature associated with the input, and y means the output or the label or the dependent feature. So when there is no easy mapping or linearity or correlation between x and y, in that case you have to map x with y using some complex type of neural network. This is the basic behind artificial neural network. So input layer is there, output layer is there. Between these two layers there are hidden layer. In this hidden layer there is multiple type of calculations combination, and based on those hidden layer calculations you will get the output. Now after that we will learn about machine learning model development. What is the meaning of machine learning, what is the meaning of feature, what is the meaning of model training and testing. Then for drug discovery we have to go for molecular representation, because machine learning does not understand what is molecule. Machine learning only understand some specific type of pattern. Say for example images or some smile type of string fashion to convert molecule into machine readable format. We have one pattern, fingerprint or smiles, that is simplified molecular input line entry system, or we have graph type of pattern, that is molecular graph. So these are various ways to convert your classical chemical compound into machine readable format, because machines don't read the molecule, machine read the specific type of input. So there are few techniques to convert chemical structures into machine readable format that we will learn in this molecular representation. We will talk about, moving on, we will talk about drug discovery. What is drug discovery? We will compare AI driven or AI mediated or AI powered or AI guided drug discovery. We will compare it with classical way of drug discovery. We will discuss about steps in AI driven drug discovery. Basically, in current world, in various pharma industry, there are two types of approaches for using AI in drug discovery. Number one, de novo drug designing. That is how to start making drug-like molecule from scratch, entirely new drug-like structure you will design in silico on the screen. It is called de novo drug designing. For this, we have to use generative type of deep learning model. Generative means there are few type of deep learning models called autoencoders, and there are three types. For example, variational autoencoder, adversarial autoencoder, and generative adversarial network, that is GANs. So this type of autoencoders are used to generate entirely new drug molecule using deep learning. This is called AI driven drug discovery through generative type of model. Another approach to discover drug is through AI driven repurposing. AI solutions, AI systems try to find various drug like molecule available in public or paid library. For example, Campbell, Zinc database, then Drug Bank, and various other sources. Or Orange Book. What is Orange Book? The US FDA managed book which has the entry of all the commercially available and FDA permitted drug molecule which are commercially hit. So from those repositories, from those databases, you will try to identify drug-like molecule for off-label usage. That is repurposing. That is repositioning. It means you are trying to find another use, off-label use, or the use which has not been recommended by FDA, but the drug molecule is available in the market, or any chemical which is not a drug molecule but it has the potential to become a drug molecule. Or one more thing is there, a drug molecule which was launched in the market, but after few years it has to be recalled from the market because of unexpected side effect. Or those drug like molecule, those drug candidates which have successfully qualified for clinical trial 1, 2, but failed in 3, but it failed in clinical trial phase 3 for particular disorder, for example A, but it can be good for treatment of B. That is to identify off-label usage of available drug or chemical is called repurposing. Here humans are not sufficiently intelligent or capable to decipher, to identify those hidden patterns. Here there is role of AI. That also we will discuss. Other than this, we will discuss general steps involved in de novo drug designing and general steps involved in machine learning model development and general steps in drug repurposing. Then we will talk about applications of AI in clinical trial, because 90% of the time drug discovery is a failed phenomena because of massive failure in clinical trial. In terms of there is a wrong mapping of the disease with the patient. For example, we want A type of customer for clinical trial of a disorder B, but we identified C type of subjects or volunteers. So it is the reason for clinical trial failure. Number 2, poor retention or highest attrition. There is high dropout of the patients or subject, I mean the volunteer, from clinical trial. Number 3 is delayed type of patient recruitment. Sometimes there is no system to recruit the patient. It takes delay. So because of all this, there is failure in the clinical trial. Here comes the role of AI. AI mines all the data available in terms of patent, research, review article, and medical history, records in terms of in terms of digital system, records of medical data, records of patient, records of earlier clinical trial. All this data is collected and given to the machine learning model. Then machine learning model identify, okay, for so and so disorder, these are the tentative or the best suited subjects we should go for clinical trial. Number 2, there is bigger hindrance because patients have to visit the reporting area or the hospital or other area to give their daily signs and symptoms or improvement, or to record their findings during clinical trial. In that case, they are reluctant to enroll themselves in the clinical trial. Here comes the role of mobile driven technology, where machine learning and AI algorithm can judge the photograph given by the patient while taking the medicament. So how and whether the patients or subjects are adhering to the clinical trial protocol or not, it can be managed by high level of application designed through AI technology. We will talk about applications of AI in manufacturing. We will talk about applications of AI in QA and QC. We will talk about applications of AI in marketing, e-pharmacy, and healthcare medical imaging, that is how to scan various type of medical images through AI. We will talk about AI in precision medicines. Then we will talk about, this is the most important, we will talk about why more and more pharma companies are shaking hands with the AI company, which are not very wealthy, not so successful, and they are not very old compared to pharma company. Why there is involvement of Intel, Google, Microsoft, IBM, and other tech company. Why there is rush for joining hands with the famous and very pioneer AI company like in silico medicine, Exhaustive, Helix, and Recursion, and benevolent AI in Cyclica. Why pharma company are ready to shake hands with the AI company? Then we will talk about some corporate success stories. Success means there are few drug-like compounds suggested by AI-driven technology, and those molecules are in various phases of clinical trial. These molecules have been given by world famous in silico medicine and Exhaustive. We will talk about their success also, and their proprietary, patented, in-house developed intelligent AI platform about this technology. Then we will go for 3-4 ready to use codes for learning, machine learning, model building, that is tutorial we will share with you. We will talk about at last AI and ethics. There are two concepts, black box and XAI. So black box means there is two concern. Machine learning should work in such a manner that human experts should be able to interpret what's going on between the input and output. Ultimately, what is going on between the hidden layer in neural network, or exactly what type of logics are being used by algorithm or machine learning model to give the output. In present system, this phenomena is lacking, but scientists are working to make machine learning model fully transparent, fully understandable, and fully interpretable by the human experts. So here comes the role of explainable AI, XAI, that is explainable AI. Here human experts design those type of AI or machine learning software, or humans are able to understand exactly what's going inside these machine learning model before giving the output. So this is summary of this course, and I assure you this is one of the most exhaustive course for AI available in this world. Yes, I am correct. So you have to read, you have to learn, you have to watch all those around 70 videos for learning the basics of AI in terms of pharmaceutical sciences. So once again, I congratulate you for enrolling in this course and proving that you are ahead of those people who still missed the enrollment and not able to do this course. So I am thankful for thank to you for enrolling, and I wish you all the luck for this beautiful journey. And in coming era, you have to reskill and upskill yourself very fast. Gone are the days when you will take one degree in 4 to 5 years and that will fade you for your life. No, you have to go for frequent up and reskilling, because market is changing very fast. As a famous quote has been given by Mark Cuban, a famous philanthropist and investor in AI startup. He says, learn AI or become dinosaur. So you have to learn in a proper manner to understand the importance of this era. And so I'm thankful to you, and with this I conclude. I wish you all the luck. Happy learning. Bye bye. Thank you.